Welcome. So we're going to be doing 5.1 and 5.2. So 5.1 is on mid-segments of triangles. Make sure you have that written down at the top. We're going to write down this box right here, which is our triangle mid-segment theorem right there. Okay. So we have a triangle, and mid-segment, basically we're going to have a segment in between the triangle. So I'll read the theorem out really quick. It says, if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side. So do you see how we have D is in the middle between C and A, and E is also in the middle between C and B. So this is in between right here, and it says that this line, this DE line, is going to be parallel to segment AB. So those two lines are parallel, as well as DE right there is going to be half as much as AB. So we know it's half, and we know it's parallel. And remember, in our previous chapter, we talked about parallel lines and the certain relationships that we have in there. And so we're going to do a few problems kind of exploring this. Okay. All right, so we got our problem number 1, and it says, make sure you write the problem out and the picture. It says, what are 3 pairs of parallel segments in triangle DEF? Alright, so we look here, we see that R is the midpoint between these two. We see that S is also the midpoint of this side, and T right here is the midpoint as well. So we know that those are all the midpoints, so that we know, using our theorem that we just had, that we can find parallel lines. So if we look at RT right here, we know that RT, that segment is going to be parallel to, which one would it be parallel to? This one over here, which is EF. EF. And then we look at, let's say, F right there. Let's say we look at TS. We're looking at this segment right here. Which one would that be parallel with? Well, the one right across from it, which is DE. And then the last one is going to be RS. RS is going to be parallel to that DF right there. DF. What's a D? DF. Okay. And so we are able to find parallel segments, but we can also start solving problems for us. So our next problem, we're going to use this information and be able to solve as well. Okay. All right. Problem number 2 that we have right here. So it says in triangle QRS, TU and B are all midpoints, and we're trying to find the lengths of TU, UB, and QR. So it says these are the midpoints. So let's mark it off first. That might be helpful to us. So we know T is a midpoint, so QT and TS are going to be congruent. U is a midpoint, so QU and UR are going to be congruent. And this last one, these two sides are also going to be congruent. So remember that it said that the two lines are parallel, and also that one segment is half the length. So we're going to use that in order to solve right here. Okay. So let's do the first one. I'll use a highlighter to kind of help me out. It says, what is the length of TU? So we have TU, which is right here, TU, this one, and we look at the one that it's parallel with, which would be RS right here. So we have, and we'll write it out right here, we know that segment RS is 40, and we know it's parallel with TU. And remember, we said that they are parallel, but the TU is also going to be half the length. So half of 40 would be 20. So we found our first one right there. Okay. So, whoops. Let's make sure I box that in right there. Alright, so that's our first one done. I'm going to kind of erase this right over here. Just kind of help us out as we're highlighting. So we have TU, we got that one done. UB right here. So we have UB, this is the length right here. That is parallel with QS. And so again, we know that those two are parallel. We know QS is 50, and so UB right here is going to be half of 50, so that's going to be 25. Alright, so we got that one right there. Our last one is we're going to find QR. Okay, so this one says that QR, this length right here, and we don't know that length, but we know it's parallel with this length right here, which is TB. So in this one, we're going to have to kind of go backwards. So this was my answer for UB right there. And these are segments, so we put little lines over the top. And we know that in this case, that segment TB right here equals 30. And we're trying to find segment QR. Well, we're just going to go the opposite way. If we know that this was half of it, in order to go back this way, all we would do is just double it. So when we take 30 times 2, that's going to give us 60 right there. So that would be how I would find those three segments right there. I know that they are half the length, and they're also parallel. Okay. Alright, this is lesson 5.2. So right at the top of the paper, we're going to be doing perpendicular and angle bisectors. Okay. So the first thing is we have a vocab word that we are going to quickly write down, and that's all we're going to do is write down this sentence right down here. We're going to say a point is equidistant from two objects if it is the same distance from the objects. So this means that a point, and if it goes to and it has equal distance, we call that equidistance. Okay, so write down that sentence right there. We're going to be using that word quite a bit. Alright, and so we have a few theorems to look at. Alright, so the first two that we're going to look at is this right here, and it is perpendicular bisector theorem. Okay, so you're going to write down everything in here and the pictures. So the theorem says this: if a point is on the perpendicular bisector of a segment, then it is the equidistance from the endpoints of the segment. So we see that right here, PM is perpendicular to AB, and we see that it is also a perpendicular bisector, which means that when we connect A and P and B and P, that these two distances are the same length, they are equidistance. Okay, and then so the one below though, is all we're doing is we're taking the converse. So we're just switching the order. All we're saying is if a point is equidistant from the endpoints of a segment, then it is the perpendicular bisector of a segment. So we're just taking it and we're flipping it. Okay, so let's go on to our next one that we have right here. And we are going to write down just this quick sentence right here, which says the distance from a point to a line is the length of the perpendicular segment from the line to the point. So all it's saying that is that the distance, the shortest distance from A to line L would be a straight line. Well, a straight line is going to cause a perpendicular angle right there. So that's all that sentence is saying. Okay? So we're going to use that sentence in our next two theorems that we have right here, which are these two. So you're going to write down both these boxes right here and the pictures. And so we have the, instead of this time, we have the angle bisector. So, and this one, and we have the converse as well to it. So it says, if a point is on the bisector of an angle, then the equidistance is from the sides of the angle. So we have this right here, it bisects it, and we have angle S right here, and the equidistance from this to these two lines is going to be congruent right there. And then all we're doing on 5.5 is we're just taking that, and now we're taking the converse right there. So we're saying if a point is in the interior of an angle, it is the equidistance from the sides of the angle. then the point is on the angle bisector. Okay. Alright, so let's do a few problems right now to just kind of clarify what all these theorems are talking about. Alright, so for the first problem right here, we're going to be using our perpendicular bisector theorem. So it says, what is the length of AB? So we're looking at this right there, and we see that we have this line right here. It is perpendicular because it makes 90 degrees, and it also bisects. We can see that from the congruent signs. So we know that the equidistance is going to be connecting these triangles, which means that the side AB right here is going to be congruent to BC. That was my perpendicular bisector theorem, because if it's perpendicular and it's bisecting, then the two sides are going to be congruent. So we know that 4x right here is going to equal 6x minus 10. Alright, now we're just solving for x. I can subtract 6x to both sides, and this is going to give me negative 2x equals negative 10. I divide both sides by negative 2, and we get x equals 5. So we found x, but that's not what we're looking for. We're looking for the length of AB. So all we have to do is we're going to plug 5 back in for the x right there. So we take 4 and we're going to times it by 5 right there, which is going to give me 20. So 20 is the length of segment AB. So that is my answer. We'll box it in right there. Alright, and we got one more left. Alright, problem our second problem, our last problem right here. It says, what is the length of RM? Okay, and so we're looking at this picture right here, and we see that this line bisects it. We see with that line, and then remember we said that the shortest distance from the line becomes perpendicular. So that's why we see these lines right there. And so we know, looking at this, that this is a perpendicular bisector, and so because we know that, our theorem tells us that these two lengths are going to be the same, or they're going to be congruent. Okay, which means that if they are the same, all I need to do is I take 7x and set it equal to 2x plus 25. Okay, so now I'm just going to get x all by itself, subtract 2x from both sides. This gives me 5x equals 25. Divide both sides by 5, and we get x equals 5. So if we know what x is, in order to figure out what Rm is, we're going to take 7 and we're going to plug that 5 back in, which is going to give us 35. So segment RM right here is going to equal 35. Okay. So as long as we know those theorems and be able to see how it bisects the shortest distance from a line, then we can be able to use those theorems to be able to solve these types of problems. Okay? Alright.